Hello, everyone. This is Tom Cooper from NoTraffic. I'd appreciate it if somebody could confirm you can actually hear my audio. I want to make sure that we don't have a communication issue here. Great. Thank you very much. Wait one more minute and get started. Hello, everyone. This is Tom Cooper from NoTraffic. I'm our Vice President of Strategic Partnerships, and I thank you for joining Chapter 3 of our webinar series, which we're going to talk about today, the intersection app model. And the all intended as reducing the complexity and cost of ITS deployments. NoTraffic is the world's first fully autonomous traffic management service platform, and I want you to keep that thought in mind, that this is actually a platform. A few things also I'd like you to keep in mind. Technology is moving to the cloud all around us. The cloud is secure, it's scalable, has unparalleled uptime. It's also future-proof because additional applications are simply added onto the application stack that you happen to be using. Technology as a service is being embraced by corporate applications, consumer applications, banking and finance applications, and perhaps one of the biggest splashes to be put into the industry is that highly secured mission-critical Defense Department applications, like the JEDI contract with the Pentagon and Microsoft, shows that's a truly scalable, secure platform. A couple other things I'd like you to keep in mind. Traffic technology and traffic management is one of the last domains to have AI introduced, artificial intelligence introduced to solve complex problems. It's also one of the last domains to migrate to the cloud. But that revolution is going to start happening, and NoTraffic is going to be part of bringing that revolution to the market. The other thing I'd like you to think about is we have the opportunity to truly digitize the intersection. So the concept is we want to evolve the intersection applications from a hardware problem to a software solution. The idea is to reduce cost and complexity. First, we'll do a short recap. So if you attended the previous two webinars, I ask you just to be patient here for a couple of minutes because I think there are some pretty interesting aspects of what we talked about. So in episode series 1, we talked about opportunities for using artificial intelligence to optimize traffic. And optimizing traffic is a major challenge for most agencies using traditional methodologies, particularly going out, taking traffic counts, developing timing plans, implementing those timing plans, and hoping that you've made enough planning for the future. With so much variability in traffic, these methodologies tend to no longer be effective. So if you look at very complex applications like crossing arterials, that in itself could be a particular challenge just when things are predictable. As traffic volumes and times become unpredictable, it's a very challenging environment. You start to getting into very complex applications like grid support. The interdependencies between timing plans and the demands, very difficult to time for. And ultimately what you're trying to do is have your policy objectives served. So the idea is we're creating this policy-driven environment, which we can talk about again later. Then you start getting to very complex environments where you have city grids that are dependent and interdependent upon highways, highway systems interdependent upon the arterials, integrated corridor management. You start thinking about the complexities, and those of you who actually do timing plans, it simply becomes impossible from a mathematics standpoint to think about all the permutations and variability in managing traffic. So fundamentally, with this artificial intelligence-driven platform that we provided, it handles all those use cases without having to generate new timing plans. So that whole process is obviated from the mix. Essentially, you use your policies, and those policies are asserted and driven through the artificial intelligence environment. So again, brief summary, this artificial intelligence environment is based upon micro simulations that run continuously, that look at all the demand from all the inputs, be the arterials, highway ramps, complex interdependencies with rail crossings and emergency vehicle preemption. Essentially what we do is we take that whole process of having to develop fixed timing plans, we create an abstraction layer so that your policies are asserted, and that's what drives the intersection decisions. Likewise, we can also take additional data sources that are relevant and create optimization. So fundamentally, we've eliminated the need to generate timing plans ever again. Chapter 2 is talking about using artificial intelligence to resolve traffic detection challenges. Almost every agency we've spoken to has said we've got problems with vehicle detection. At the lowest level form, loops break. They don't do things more than just tell you there's actually something sitting there. So sophisticated advanced applications can't be served by loops. We also hear continuously that our video detection misses a lot of vehicles. And if it misses a lot of vehicles at times that are really important, it can have a major impact on traffic flow and also safety. So fundamentally, what we do in our sensing environment, I'm going to call it sensing versus detection because this infers a lot more. We use multiple sensory inputs using radar and video to capture all the use cases and all the physics challenges behind sensing and detecting objects, objects being vehicles and pedestrians and bicyclists and scooters. And we use this deep learning AI and edge-based processing to give high accuracy in all conditions, because there are many conditions where existing detection forms simply do not work. So in our world, we use radar, video, and edge-based processing for artificial intelligence algorithms to come up with a very high level of presence accuracy, approaching 100%, and also a high degree of classifying what the object types are at the intersections. So that multiple sensory inputs in AI is better than just a standard singular form of detection. Cases like inclement weather, very challenging for detection. Shadowing, typically a big challenge for detection accuracy. Nighttime. So if we happen to be a pedestrian walking across that intersection, missed vehicles, that could be a safety issue. So we hear these things over and over again. Even just the base level detection seems to be deficient in many different cases. And if you look at the statistics behind that, even if you had an existing detection system that was 98% accurate, that means it's 2% inaccurate. That's 1 week out of the year where the detection is not working. So if that's missing vehicles, if that's missing pedestrians at all the wrong times, that could be a really big issue, particularly as it relates to safety. So again, multiple sensory inputs. It also gives us an extensive array of algorithms to provide insights at the intersections. So for example, now I've got this very intelligent sensor. I can classify the object types. I can track their movements. I can count them. I can make predictions based on what's going to happen, but I also have a very broad portfolio of what's happening in there from a safety standpoint and also what is going to happen as well. And this is all by having an AI-driven edge-based processing environment. Things like wrong way running. Since I've got these intelligent sensors, I'm tracking vectors of vehicles, I'm tracking vectors of objects, so I can provide a lot of insights and alerts about what's happening from a safety perspective. Additionally, things like accidents for accident recreation. What you're seeing on the left-hand side of the lower block, there's an actual incident in an intersection that was immediately reported as an alert. What you're seeing on the right-hand side, that's the metadata associated to that. So it's easy to do accident recreations to get additional safety insights. And also giving agencies some idea of what's happening at the intersections before motorists complain. So we've got things, people in the streets or work zones or debris in the roadways. So by having really smart sensors, you can do all those functions, not just pure detection. So now we'll focus on the main topic for this webinar. This webinar started out, I started asking agencies questions about what does it really cost to build an intersection? I got two answers very consistently. The first was, well, it depends. The second answer I got was, well, it's a lot. And I consistently got answers, so I figured I'm going to apply some more science to this. Let me do some analysis. So the Federal Highway Administration has a website, looks at ITS system costs from the Joint Program Office. And I started going through that. So fiber optic network in Colorado, $2.5 million for 17 miles. Seems like it's pretty expensive, but okay. A citywide vehicle detection system for 63 intersections, 1.5 million. Okay. Then I started seeing this pattern of, well, it depends and it's a lot. The common thread is these are single-use platforms that have to be installed with a hardware investment and an ongoing maintenance investment. And this continued through the research. So detection technology at 17 intersections for $350,000. It depends, and it's a lot. Transit signal priority, $500,000 for, it was really just a handful of intersections important in Portland. Again, single application, single hardware architecture, it depends, it's a lot. And it's continuing to go on. One of my favorite categories, it depends, it's a lot, is adaptive traffic control. Because there are so many dependencies on existing detection, communications, back-end systems, controllers, that category seemed to be really all over the map in terms of actual cost. And what that distills down to is it's a major challenge for agencies to fund these projects initially, but also to maintain them seems to be a tremendous burden for a lot of agencies itself. Then you start talking about connected vehicle applications. Typically, you acquire roadside units. So a roadside unit with a cost ranging from $443,000 to $644,000 for intersections. And again, example of it depends, and it's a lot. A red light extension system on 2 approaches at intersection at $16,000. A single hardware installation, additional cost, additional maintenance, additional support. Again, we revisit the adaptive category. My favorite category of it depends and it's a lot. So I think we saw a common theme here is that there's not a lot of predictability in terms of price, particularly as agencies have to acquire different pieces of technology, specifically hardware-based, to serve specific applications. Then we revisit the whole idea of roadside units and connected autonomous vehicle support. To put more science behind this, we actually interviewed a number of our customers in our customer base and came up with some hard numbers. So traditionally, video detection, just itself, plain vanilla video detection, is about $20,000 per intersection for just acquisition cost. An ongoing operational cost could be $600 to $1,000 per intersection. So a total lifetime cost could be pretty expensive. And in fact, the lifetime cost for a video detection system is more than my entire platform at an intersection. We'll get back to that a little bit later. Signal retiming, if you have to do that, that's a contributor to the ongoing maintenance costs. Separate systems like emergency vehicle preemption systems. Typically, it's a different vendor, a different product, different hardware installation, ongoing maintenance support. Pedestrian detection systems, for adding pedestrian detection systems to the intersection, typically additional hardware, additional installation, additional maintenance, additional support costs, and on and on and on. Bluetooth travel time can cost $4,000 per intersection. Fiber optics, another area where it depends and it's a lot, applies greatly because you've got a lot of environmental conditions to consider and geotechnical issues to consider. Then back to my favorite category of adaptive. I mean, if you were to spend $40,000 per intersection, and then the lifetime cost of that could be exorbitant. So you start saying that a traditional ITS budget is based upon individual, monolithic, single-use solutions, additional hardware, additional installation, additional maintenance, additional support. So I think we've got some perspective here. There's been a major revolution and evolution in several key technology-based markets. In aviation, in medicine, in banking and finance. I think one market that's particularly applicable in terms of how it's evolved from a hardware-based environment to a software-based environment is the consumer electronics market space and revolution. So I go back to this quote. I gave Dr. Einstein here a very short shrift, but I think this is a very apropos quote that if you want to know the future, look at the past. We've got an example right in front of us. And that's specifically in the consumer electronics revolution. I submit this really started not with the brick phones and the bag phones, but it really started with the first mass-produced, low-cost communication device. Happens to be a Motorola StarTAC, one of my favorite phones of all time. So a single-use device for a purpose. And what was happening at this time? Miniaturization was happening. Transistors and storage, prices were coming down and storage was going up. So if you wanted to carry your music with you, you could get an iPod, which could literally carry 1,000 songs. What a breakthrough. Then you could get a time source on your wrist that used a satellite-based feed to update the time and make sure it's accurate. Then you have a personal communications device, PDA. I kind of date myself because I tell you what that actually is, but that you're buying single pieces of hardware for a single application. Digital photos. You got a digital camera. If you wanted to do video, you bought a video camera. If you want to record voice recordings, the best way to do that was an external voice recorder. If you want to watch content, this could actually be a portable device. You had a hand truck, but that's really where the content delivery was, right? It was broadcast television. Applications like scientific calculators and GPS and biometrics. So that market very quickly started to evolve to a platform, a software and a cloud-based application platform with the smartphone. The smartphone itself is an application delivery device that leverages the cloud that lets you use a base hardware platform to serve multiple applications. And we believe that this market in transportation is going to go along the same revolutionary than evolutionary path. So if we compare that to the traditional traffic legacy landscape, and before I bring up this slide, I have to give you a word from our legal department that any resemblance to actual traffic products on this slide is purely intentional. So the basis of the current state of traffic management is the humble traffic signal controller, which is essentially doing the same thing it's done for 100 years. It's emulated a traffic cop who has emulated electromechanical timer to replace the traffic control officer, which is essentially just running fixed timing programs. Now, granted, there's some sophistication with newer models, but fundamentally, that's how these things work. You buy a single product, single hardware product from a vendor, has to be installed. Then you have to add communications to the mix. If you want to do any advanced features, capturing analytics, controlling signals, you have to add communications into the mix. Detection. So if you want to do anything more sophisticated than just loops, you need detection. And since detection doesn't work most of the time or some of the time, then you have to add radar. Another piece of hardware, another hardware install, another capital investment, more maintenance cost, and so on. So if you continue to add applications today with the legacy infrastructure approach, you're adding additional pieces. So connected autonomous vehicle support, a roadway unit, or RSU, roadside unit at the intersection. Want to do Bluetooth travel time, another piece of hardware. If I want to bring in software content, so software content being an ATMS or an ATSPM product, that's typically another product, another vendor, another capital expenditure, more hardware to support that. If I want to add TSP or VP support, again, typically it's another vendor, another piece of hardware, another installation, more ongoing maintenance. Then when you start doing large back-end systems, that's where the costs really start coming up significantly. So large-scale ATMS platform, large-scale adaptive traffic management platform starts entering millions and millions of dollars. Again, another capital investment, another installation, more ongoing maintenance, ongoing support, and things like the white black box that goes in the cabinet that's just adaptive control. So we've seen this model before. This model is going to be transformed. And it's going to be transformed fundamentally because the technology is now available by a multi-use platform that can drive applications to the intersection. So I posed the question then, why can't agencies just install intersection apps rather than single purpose expensive add-on systems? Because I think we've got a good sense now of the typical installation at an intersection is an expensive add-on from perhaps a different vendor, requires a lot of different maintenance and support. So let's go back to this analogy. So this device we discussed is really an application delivery platform. It's much more than a smartphone. So it comes typically with baseline apps. So one of my favorite baseline apps, but one of my least favorite apps if you have teenage or adult children is this thing. So they hate when you actually use this on them. But I digress. So we're back to the topic at hand of I've got this fundamental hardware architecture that can deliver multiple applications without having to do any additional hardware installs beyond this really smart sensing environment, this communications device, which connects to the cabinets, runs algorithms, and this policy-driven back-end system that's cloud-based that has capabilities of rendering analytics and other specific applications. So essentially what this does is it solves the problem of digitizing intersection by turning a hardware issue and a problem and challenges into a software-based solution, much like the smartphone. So we've got this construct of a very, very intelligent sensing environment that has multiple input capabilities and edge processing to deal with inclement weather, shade, fog, other things that happen at the intersection. You give us insights into intersection activities, safety insights, have a universal communications device that can talk to any controller type and can run whatever applications you need it to run. And all being tied together by this cloud-based service model that gives me a lot of flexibility and future-proof insurance. So then this ushers in this whole concept then of an application model at the intersection. So this is not a one-size-fits-all proposition. Agencies can select the feature sets from our platform that serve specific purposes. Fundamentally, all the applications are built upon this artificial intelligence optimization capability, which is able to take inputs from all the modules, all the sensors, and make intelligent decisions. However, if the agencies just want to remain in this fixed timing construct, there are certainly benefits to the platform beyond the optimization piece. There is integrated travel time and origin destination support. That's inherent in the hardware architecture. So that's not something you have to invest in individually. It's not separate hardware, it's integrated hardware. Transit signal priority. I have inherent capability to support that feature from this platform directly. And if I've already got an existing TSP system, I can use that knowledge and I can factor that into optimization for using that. I also have native support for emergency vehicle preemption. So again, these are applications you're simply enabling in software. When I start moving into more advanced applications like ATSPMs, that's something that's available through the cloud connection. It's not a separate acquisition. It's part of the platform itself. You decide if you're going to enable that. Green light delay or red light extension applications. Traditionally, that's been a separate hardware system. I serve that feature from the platform itself. We start moving on to some more hardware-centric things like roadside units with connected autonomous vehicle support. I've got that capability integrated to the system now, and all these functions are fully integrated. So I also don't have the burden of integrating and maintaining a multi-vendor solution. There's an emerging application of freight priority. It's getting a lot of interest from areas that have large distribution centers. Again, this is an application I can serve from the same platform by just setting policy decisions in the dashboard for managing the NoTraffic platform. And back to this category then of insights. So I think I showed you the example of wrong-way driving, safety insights. Since I've got the smart sensors, I can determine and alert on anomalous behaviors at the intersection. I showed you an example of safety insights where I actually captured an anomalous behavior, which is an accident. So that would definitely warrant some more investigation on the agency's part to rectify that. And just incidents in general. We've heard over and over again, many agencies don't know when work zones are set up. They don't know if there's debris on the roadway until they actually get motorist complaints. So it gives the agencies the ability to be very proactive now about managing traffic around these situations, these use cases. And the last piece is new applications are simple downloads. So if you go back to the smartphone analogy, all I need to do is leverage the same platform, download new applications. So an application will be released here in the very near future is touchless pedestrians. As I showed you through the sensing environment, we can detect pedestrians at the intersections. There's some clarity that we're waiting for from FHWA related to how this is actually treated and actually handled. Simple software download. So this model then delivers multiple features without additional hardware installation, without additional maintenance, without additional ongoing support, and also it'll all work together because it's coming from one vendor. So this application model unlocks several things. By digitizing the intersection, we are solving a hardware problem with a software solution. NoTraffic provides an end-to-end intersection management software platform. So I keep going back to software. The enabling hardware is leveraged for multiple applications. What this does, obviously, it reduces the cost dramatically because I'm not investing in different hardware pieces. I'm not getting into different maintenance agreements. I really want to have to maintain one singular set of hardware for the applications. And since new apps are simple software upgrades, it's future-proof because future applications are going to be downloads, but I can also test and evaluate features without going through a complex acquisition process through purchasing. I can download apps, test them, evaluate them, and if they fit into your operating environment, that's a great thing, and you can expand and can use it. So there's no reason to actually have to make investments into additional installations for applications because you've got the capability of doing that through the platform itself. So this is going to be the end of my slides. I see I've got a couple of questions. We'll handle questions at this point. And let's see what we've got. Where do you obtain bus scheduling for using and implementing TSP? So Jeff, great question. I'm glad you joined. We can take any external data. So for example, if there's bus scheduling that's published by an agency, we've got a pretty extensible API environment to ingest that data so we can understand what's happening, for the scheduling. We can, if there's onboard units that are telling us transit signals are coming in, we know the proximity of them. We can deal with all the headway management, and we can actually report back to the agencies itself. So our API interface is fairly extensible, and I can show you at some point the objects that we publish out of that. So that's how we would do that from a scheduling standpoint. Just as pure extensions, we can do that a couple of different ways. If there's an onboard AVL platform, or you can even instrument transit vehicles with just simple OBUs, because there are a couple of them out there that we've worked with that are off the shelf that can drive that application. So hopefully that answered your question. Other questions? Okay, well, I take that to be no more questions. One more. That's actually a great question. So if you have any suggestions for additional apps, please contact us, because we're actually going through the process right now with developing and rolling out our roadmap for future applications. So I'm not promoting this right now as an open architecture application platform. However, we can deploy things very, very quickly. So some of the things we're getting questions about, we're getting questions from outside the transportation industry of potential consumers of traffic data. So things like driving connected autonomous vehicle applications, us being the conduit for that, or safety insights related to insurance or what have you. So this is a very extensible platform. If you've got some ideas from future apps, love to hear about that. I'd love to hear about existing problems you may have with detection and optimization and some of the other feature sets. Any more questions? I think that's it. So everyone, thank you very much. We appreciate your attendance and really value the time you invested here. Again, I'm Tom Cooper. Here's my contact information. If you have any additional questions, like any follow-up on this, be glad to do that. We'll be holding webinars throughout the rest of the year. And if you have any ideas for topics you'd like to cover as well, please submit those, and we'd be grateful to have them, and look forward to seeing you on the next webinar.